welcome you to this channel, and I want to appreciate everyone who has subscribed and shared this video. I will encourage you to continue to share this with your friends so they can benefit from content like this. So in this particular video, we're going to be solving questions from the October-November 2023 paper 2. It's an extended paper, and of course you see that it's a paper that should last for 45 minutes. So you have to be really fast and accurate when it comes to solving the objective multiple choice questions. So let's go straight to solving the questions. Now the first question says that a sample of gas occupies 340 centimeter cube. So this is the volume of the gas. Now the temperature and pressure are both increased, and the volume of the gas, please take note, remains the same. So what happens to the particle speed and the average distance when the temperature and the pressure are increased and the volume remains the same? So you have from the prior information that when you increase the temperature, the particles will collide, samples of gas particles will collide more frequently, and that means the speed of the particles will increase. So option A and B are off, so we're left with C and D. So of course it should increase because they collide more frequently due to the increase in the temperature. Now, what then happens to the average distance between the particles? Because the pressure is equally increased and the volume remains the same, the average distance between the particles equally remains unchanged. All right, so let's go to the next question. Which statements about the rate of diffusion of the gases ammonia, carbon monoxide, nitrogen, and oxygen are correct? So for us to be able to relate information on the rate of diffusion, we have to get the masses of the gases. So ammonia is NH3 and it should have a mass of 17. Carbon monoxide should have a mass of 28, that is 12 plus 16. Nitrogen should have a mass of 28 as well, and oxygen, which is O2, should have a mass of 32. Now nitrogen and carbon monoxide will diffuse at the same rates. That's true because they have the same mass, so they should diffuse at the same rates. Now oxygen will diffuse slowest because it's an element, whereas the others are compound. No, that is not correct. Okay, so this is off. And then ammonia will diffuse fastest. That is correct because it has the smallest mass. So any option involving 2 is wrong. So 2 is wrong, and then we are left with B because that's the most correct answer there. The structure of an atom of an element X is shown. So you are given the number of protons and neutrons in the nucleus. So we use the number of protons to identify the element because the number of protons is the same thing as the atomic number. So if you are not too sure, consult the periodic table. Look for an element with proton number 5 or atomic number 5. You see that is boron. Which statement explains why isotopes of an element have the same chemical properties? Remember that isotopes are atoms of the same element with the same number of protons but different number of neutrons. Now, for them to have the same number of protons but different number of neutrons, all right, so what affects their chemical reactions is the number of electrons in the outer shell, because that is what they use in participating in bonding, and that is how they react. So C is the answer to that. Magnesium reacts with oxygen to form magnesium oxide. What happens to the magnesium atoms and oxygen atoms during this reaction? Now, magnesium oxide, the kind of bond there is simply an ionic bond. An ionic bond involves the transfer of electrons, okay, from an electropositive such as magnesium to a less electropositive. So it means if you look at the configuration of magnesium 12, so it's 282. Oxygen with proton number 8 is 26. So magnesium will transfer 2 electrons to oxygen, and you have to look for an option that aligns with that thought. So you look at option D. Magnesium loses 2 electrons and oxygen gains the 2 electrons to complete the octet structure here. So D is the answer to this. Which row about the properties of both diamond and silicon 4 oxide is correct? I need to remember that diamond and silicon 4 oxide are simply giant covalent structures. Now, diamond do not conduct electricity. Silicon 4 oxide as well, being a covalent compound, does not conduct electricity. So these and these are off. So we're left with the fact that they are giant covalent structures and they do not conduct electricity. For question 7, the equation represents the reaction between solid magnesium oxide and dilute hydrochloric acid. So for the fact that it's dilute hydrochloric acid, okay, we have to pick out the row that states the symbols of every of this. So because it's dilute, it is aqueous. Okay, and then magnesium chloride, of course, the salt will still contain some amount of water, which makes it aqueous, and then liquid. So option A is the answer to this. Which substance is a mixture? Okay, so all of these here are, compounds. This is oxygen as an element, and then this is graphite as a compound. So air is a mixture of gases. Number of moles of atoms X, Y, Z in a compound are shown. So what's the formula of a compound? So once you get the formula of a compound, X, Y, Z. So this is 0.6, 1.2, and 0.3. So we divide by the lowest number, 0.3, 0.3, 0.3. So this we have 2, for this we have 4, and for this we have 1. So we have X2, Y4, Z. So D is simply the answer to this. 1 mole of silver nitrate contains 1.2 times 10 to the power 24 ions. How many ions are there in 0.25 moles of iron 3 oxide? So first is the relationship that relates, the formula that relates everything is that the number of moles, so let's say moles is the number of ions divided by 6.02 times 10 to the power 23. So we have the number of moles, we have to find the number of ions, but we also have to factor in what happens, number of ions here when it is dissociated, before we multiply it with the Avogadro's constant. So if we have Fe2O3, it simply means that there are 2 Fe3 plus ions, and there are 3 oxygen anions. So that means 2 ions of iron or 3 ions of oxygen. So if you add that, that's about 5. So to get the number of ions now, so number of ions will be equivalent to, what's the total number of ions when they are dissociated? 5 times number of moles 0.25 times Avogadro's constant 6.02 times 10 to the power 23. So you multiply that, you have C as the answer to the question. Okay, so we have to factor in number of ions when it is dissociated. Now, concentrated aqueous bromide is electrolyzed using carbon electrodes. Write which equations represent the reactions occurring at each electrode. So the positive electrode and the negative electrode. Remember that the negative electrode is the cathode, and the positive electrode is the anode. Now, the positive electrode is supposed to attract negative. Okay, you're supposed to, so you should have the anions going to the anode. Okay, so in this case, look at the options. Which one is not a negative ion? So B is not a negative ion. C equally is not. So we are left with option A and D to contend with. All right, and the same thing applies to this angle. Okay, but let's also look at it this way. So if you are looking at concentrated aqueous magnesium bromide, what are the cations involved in the solution, and what are the anions involved? So for the cations, we have magnesium 2+, and since it's an aqueous solution, you also have the hydrogen ion there. So for the anions, we have the bromide ion, and then we have OH-. Now, from your knowledge of electrolysis, when we are dealing with a concentrated aqueous solution, the hydrogen goes to the cathode, and the halogen or the halide goes to the anode, while the solution becomes the magnesium hydroxide. Okay, so in this case, like we said, this goes to the cathode and this goes to the anode. So you see that option A rhymes with that. So that's the template for concentrated aqueous solutions of the salt. So the hydrogen goes to the cathode, and the bromide or the halogens goes to the anode. Just learn that as a template. Now in this case, question 12. Now, aqueous copper 2 sulfate is electrolyzed using carbon electrodes. So which statement is correct? Now, bubbles of hydrogen gas are formed at the anode. Okay, let's look at the ions, cations and anions once again. So remember the cations and the anions. So the cations, aqueous copper 2 sulfate, so copper 2+ and hydrogen ion. And then for the anions, there's the sulfate ion and the hydroxide ion. So this goes to cathode, and this is the anode. So this should be attracted to the anode, this should be attracted to the cathode. Now, the cathode is negative electrode, the anode is the positive one. So both of them, you see that hydrogen is more reactive than copper in the reactivity series. So hydrogen stays in the solution, copper is displaced and deposited at the cathode. Okay, so copper should be deposited at the cathode. But where we have bubbles of oxygen gas are formed at the cathode is wrong. Bubbles of hydrogen gas are formed at the cathode is wrong, because copper should be there. Copper is deposited at the anode, wrong, because copper should go to the cathode. So you can see we've eliminated all of the options and we are only left with one correct option. And that's true, because in the solution, copper 2 sulfate is a blue solution. So as copper is deposited, as it loses ions and goes to the cathode, the color of the solution fades off. So the blue fades off because copper is being lost. All right, so this is one method to solve. This is a very good method to solve objective questions. It saves you a lot of time and you become more accurate. Now, this is another question. We're looking at hydrated iron 3 chloride, and the forward reaction is exothermic. So this is an exothermic reaction, forward. So if the forward reaction is exothermic, it says what energy pathway represents, what reaction pathway rather represents the reverse reaction. So the reverse reaction is going to be endothermic, since the forward is exothermic. Now, let's eliminate again. So for the reverse, that is, this becomes the reactant for the reverse. So let's look at the pathways. Which one doesn't have the hydrated salt as the reactant? This doesn't have it, because this is the product again, and C again is also wrong. So we are left with option B and C because they contain the hydrated salt as the reactant. Now, for us to have an endothermic reaction, the energy of the product should be more than the energy of the reactant. So the energy of the product minus the energy of the reactant should give us a positive value in this case. So if we look at this, this is higher than this. So this would have a higher value than this. And when we subtract it, we have a positive value, which makes it an endothermic reaction. But for the second D, this is lower. So the energy of the product is lower than the energy of the reactant. And when we do our subtraction, we have a negative value, which makes it exothermic. So from this proof, we see that option B is correct, because it has to be an endothermic reaction for the reverse. So go to question 14. Now this has to do with bond breaking and bond forming. So for us to get the energy change of the reaction, get the energy required to break the bonds, and get the energy required to form this. So the energy required to break the bonds first is C2H4. So we have 4 hydrogens attached to 2 carbon. Right. So ethene reacts with hydrogen. So we have 4 CH bonds plus a carbon, one carbon double bond. So we add that up. So let's use the calculator in this case to do a lot of calculations. So if you do the calculation, so 4 CH bonds plus carbon double bond. So 4 times this will get you a value, plus this carbon double bonds, you should have a value of 2686 kilojoule per mole, just to save time. Okay, and then for the energy required to form the product, C2H6 means there are 4 CH bond and there are 1 single double bond. Sorry, there are 6 CH bonds rather. 6 CH bonds, because if you draw C2H6, you see that hydrogen is attached to the 3 hydrogens, each is attached to the carbon. So 3 here, that's 6. So if you do that, you add this up, 6 times CH bonds plus carbon single bond, you have 2810 kilojoule per mole. So this is for forming the product, and this is for breaking the bonds. Now if you do this, so the next thing is you're going to subtract to get the energy change of the reaction. It's going to be energy change of the reaction now is going to be 2686. That's the energy of the reactant. That's the energy required to break the bonds minus the energy required to form the product. So if you do this subtraction, you have B as the answer. So that's how to solve questions like that. Now question 15, we have statements about 4 different acids. A particular concentration of hydrochloric acid has a pH of 2. The same concentration of ethanoic acid has a pH of 3.4. We are also told that hydrobromic acid is a strong acid. Ethanoic acid is slightly stronger than trimethyl ethanoic acid. Okay. So what are the pH values of the same concentration of hydrobromic acid? Now we already told that hydrobromic acid is a strong acid, and since it has the same concentration as hydrochloric acid, it should have the same pH because they are both strong acids. So anything involving 3.4 is wrong. So we are left with AB because pH of 2 is what should be in line with the answer. So I left you two options now. Now let's go to the second part. See the same concentration of trimethyl ethanoic. What will be the pH? We're told that ethanoic acid is slightly stronger. So it to be a slightly stronger acid, it has a lesser value in terms of pH. So that means trimethyl ethanoic should have a value very close to 3.4, but is higher than 3.4. So B is the most suitable answer to that, because 3.5 tilts more towards the neutral position, which makes it less acidic compared to ethanoic acid. Right, so moving forward. Anhydrous cobaltyl chloride is blue and it turns pink when water is added. That's a test for water. How do you reverse the reaction? Just reverse it by heating it. That's all. The reaction between nitrogen and nitrogen is reversible. The forward reaction is exothermic. What change to the conditions will increase the yield of ammonia? So for the Haber process, you want to increase the yield of ammonia. Of course, catalyst has already been added. Okay, for us to even form this, the catalyst has played its role. So it's definitely not adding the catalyst. Okay. Now, increasing the temperature, because it's an exothermic reaction, increasing the temperature will favor the reactant. So you have more of the reactant than the product. But when you increase the pressure, why will increasing the pressure affect? How will increasing the pressure affect the reaction? Let's look at the total volume of the reactant. So 1 year plus 3 years. So 4 volumes are involved, or 4 moles are involved here. And then for here, we have 2 volumes are involved. So increasing the pressure will favor the side with lesser volume. So if we look at both sides, you see this has a lesser volume, and it's where we have the ammonia. So increasing the pressure would increase the yield of ammonia, because increasing the pressure favors the side with lesser amount of volume. Ethanol can be turned into ethanoic acid by passing it over hot copper through oxide. What is this type of reaction? So we see that it's not a neutralization reaction because it's not an acid and a base or an alkali reactant. Now look at ethanol. Addition of oxygen to ethanol is what forms the ethanoic. That means the ethanol has been oxidized to ethanoic, and then copper that gives off the oxygen has been reduced from +2 to 0 in terms of oxidation. So in this case, it's a redox reaction because oxidation is occurring, equally reduction is occurring. So redox is the answer to this. When heated strongly, silicon 4 oxide reacts with carbon, which term describes what happens to silicon 4 oxide. Still not neutralization reaction because there are no acid and bases or acid and alkalis here. But let's look at it. Silicon is +4 here and it becomes 0 here. And then the same thing with carbon. Carbon moves from 0 to +2 here. So this is a redox reaction as well, but we are concerned with silicon 4 oxide. So silicon +4 to 0, that's a reduction because there's a decrease in the oxidation number. So reduction is the answer to that. Which statement about aqueous weak acids is correct? Now, weak acids are always dilute aqueous solution. Not always. So this is not correct. Weak acids dissociate fully. Of course, that's opposite. Strong acids dissociate fully. Weak acid, when a weak acid is added to blue litmus paper, it stays blue. No. Okay, because to demonstrate the acidity property by turning the blue litmus paper red, whether weak or strong. When a weak acid is added to sodium magnesium, effervescence is seen. This is the correct answer because magnesium displaces the hydrogen in the weak acid, and that gas is hydrogen, giving off as an effervescence is seen. Which oxides are basic? Of course, we are told that most metal oxides are basic, except we have the aluminum oxide, and we also have zinc oxide. Okay, so but every other one is a basic oxide. So A, 1, 2, and 3. Zinc oxide is an amphoteric oxide. Okay, it's added to excess dilute hydrochloric acid. Of course, when it is added to excess dilute hydrochloric acid, it behaves as a base on an alkali. Okay, a base here, it behaves as a base here, and then for this other case, it behaves as an acid because you're adding it to an alkali. So in this case, it's going to form a salt, and that is why we have colorless solutions formed. Now 23, which role shows the property of an element that is in the same group of the periodic table as lithium? Now lithium is a metal, and therefore in the group you should have other metals. Now metals, you have high electrical conductivity, and that cancels out C and D, but their densities will not be as high as other metals like the transition or other group metals. So option A should be, because this is not a high density. The elements in group 7 include chlorine, bromine, and iodine. Which statements are correct? Now, iodine is more dense than chlorine. That's true. Iodine displaces chlorine from a solution. That is off, because chlorine is more reactive or more electronegative. So chlorine should displace iodine, not iodine displacing chlorine. So let's look at our options. Where do we have two? A off, this off. Now, bromine is a diatomic non-metal. That's correct. Okay, so we have 1 and 3 because halogens generally are diatomic, so they're all diatomic in nature. So 1 and 3, not 1 and 4. Chlorine is darker in color than bromine. No. So 1 and 3 is the answer to that. Cobalt is a transition element. No, transition elements generally form colored compounds. So A, they have high electrical conductivity, they have high density, they have high melting point. So that's what makes the 3 options wrong. Which metal has variable oxidation numbers? Transition elements generally, transition metals have variable oxidation states. Okay, aluminium has a single oxidation state of +3, calcium +2, sodium +1. So just a single oxidation state. Which statement about alloys is correct? Alloys are pure metal elements. No. At least 2 or more metals react together to form alloys. Not in all cases. Alloy can be other. True. Steel is not an alloy. Of course, steel is an alloy. So C is the answer to that. A metal M is between sodium and magnesium in the reactivity series. So we have sodium and we have magnesium. Metal in between them should likely be calcium. So which reactions occur with M and its oxide? Now, does calcium react with steam? Yes, calcium reacts with steam. So option A and B are off. Now, can M be extracted by heating its oxide with carbon? No, because carbon will struggle to displace calcium. Because look at the reactivity series, carbon is way below calcium. So it will struggle to displace calcium, and therefore C is the answer. The diagram shows experiments to investigate the rusting of iron nails. In which test tubes do the nails rust? Of course, we all know that the nails will rust in 1 and 2, and not in the test tube 3. The layer of oil as well as the tube will prevent oxygen coming into this system. Which equation represents a reaction that takes place when iron is extracted from its ore in the blast furnace? Of course, you know this is the equation because this equation shows how the impurities in the extraction process are removed to form the calcium silicate. Sorry about that. Trying to go back to this. Okay. Some uses of water are listed. From which uses is it necessary to chlorinate? Now, we chlorinate the water to kill germs, and kill germs because you don't want it to be harmful when humans consume it. So for drinking and in swimming pools, aligns with consumption. Oxides of nitrogen are formed in car engines. Okay, what happens to the oxide of nitrogen in the catalytic converter? So if we have an oxide of nitrogen like this reacting with carbon monoxide, okay, we would have nitrogen oxide, then carbon dioxide giving off. Now, in this case, we see that the oxidation number of nitrogen has reduced from, we see that it is now from +2 to 0, and that's a reduction. So simply a reduction has taken place there. Which pair of compounds are structural isomers of each other? For them to be structural isomers, they should have the same number of carbon atoms and hydrogen atoms, but different structural formulas. That is, they are arranged in a different way. So if you look at this, is off because this is 4 carbons and this is 3 carbons and 4. So this is not a structural isomer. This contains the same number of carbon and hydrogens, but they happen to be the same thing in terms of naming. So it's propene in both cases. For this one, it is still the same thing, 3 carbon atoms, propanol in both cases. But for this, it's a different, same number of carbon atoms and hydrogen atoms and oxygen, but different structures. So this is a carboxylic acid is an ester, which shows it's a different arrangement, but the same number of carbon atoms and hydrogen atoms. Methane reacts with chlorine in sunlight. Now, whenever methane reacts with chlorine, 2 products are formed. because a group replaces another group, okay? And that is not an addition reaction. So anything addition is off. So 2, anything having 2 is off. So I left it A and B. Now you're told that sunlight is present, which makes it a photochemical reaction. There is no catalyst needed there. So 1 and 3 is the answer. For question 35, propene. So this is propene reacts with bromine to give a single product because an addition reaction. So in this case, when bromine comes in, it breaks the double bond, attaches itself to the 2 carbon atoms in between the double bond. So the new product becomes CH3, CHBr, CH2Br. So this is what happens when the addition reaction of propane with bromine. So we see option C aligns with what we have there. Now, ethanol can be manufactured by fermentation. We are given certain statements and ask which of them describe an advantage. A low yield of ethanol is not an advantage. Batch process means it's going to take longer, okay, which is not an advantage. So the process takes place at a lower temperature. So we look at 1 and 2. Anything 1 and 2 is off. 1, 1, 2. So we have straight answer 3 and 4. So lower temperature because of the presence of yeast, and is a renewable source because you use glucose. Now we have reaction. Ethanol reacts to form ethanoic acid, because that is oxidation, and then this one reacts to form this ethanoic and ethanol, that's esterification. So option A is the answer. Okay, so 38 now. We have that petroleum. How do we have petroleum to fuel oil? That's fractional distillation, and then from this fuel oil to ethane, that's cracking, and ethane to this is polymerization. So C is the answer to that. And then for question 39, RF values are used to identify unknown substances using paper chromatography. Now, RF values are always less than 1. That is correct. RF value is distance traveled by solvent divided by distance traveled by unknown substance. This is wrong. It should be the reverse. So anything 2 is wrong. Anything that contains 2 is wrong. So I left with 1 and 3. So the answer is B, because the RF value, the higher the RF value, the further the unknown substance travels. That's true. And the RF values are not affected by solubility is wrong. They are affected by the solubility of the unknown substance. 40, which is the last question. The results of some tests on an aqueous solution of substance X are listed. Now, we have a cream precipitate produced when you add aqueous silver nitrate. You are testing for an halide here. Either any of the halogens, whether chlorine, bromine, iodine, or fluorine. So because there's a cream precipitate there, is bromine. Bromide ion is likely there. So everything chlorine is off. Alright? So I left you 2 options, A and C. Now, we add aqueous sodium hydroxide, it produces a green precipitate. Green precipitate is likely either chromium 3 or ion 2, right, for green. But we look at how do they react. It dissolves in excess alkali. Okay? Now, when you now add it to aqueous, when you add aqueous ammonia, it produces the same green, which is now insoluble in excess. And that is what makes it chromium. Okay? Chromium is insoluble in excess ammonia, while ion 2 is the opposite. So A is the answer to that. And that is the end of this particular video.
I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you are giving to them. Thank you very much, and I'll see you in my next video. Bye bye.